Walk into any factory and two things are true. The big motors run on three-phase power, and every transformer is rated in kilovolt amps, not kilowatts. Both of those confuse people. Why three phases instead of one? And why rate a machine in kilovolt amps when the work is measured in watts? The answers are simpler than they sound. Let's take them one at a time. Start with single phase, the power in your house. It's one sine wave, and its power actually pulses, dropping all the way to zero 120 times a second. Three phase uses three separate waves, each shifted by a third of a cycle, 120 degrees apart. As one wave dips, another is peaking. Add all three, and the total power comes out smooth and constant. It never falls to zero. That smoothness buys two huge things. First, those three staggered coils create a magnetic field that actually rotates. Drop a motor into that rotating field and it just spins, all on its own. A single phase motor needs extra tricks just to start turning. Second, three phase moves more power with less copper. Three modest wires beat two big ones. Cheaper to build and cheaper to run. Now the second question. Kilowatts versus kilovolt amps. What's the difference? Kilowatts are real power. The actual work getting done. Heat, torque, light. Kilovolt amps are apparent power. Simply the volts times the amps that the equipment is actually carrying. When the power factor is less than 1, those two numbers are not the same. The volt amps are always the bigger one. So why does the nameplate say kilovolt amps? Because a transformer has two hard limits. Voltage, set by its insulation, and current, set by heat. Both of those are about volts and amps. Volt amps, not watts. The iron and copper don't care how much real work the load is doing. Rate it in kilowatts, and the number would change with every customer's power factor. The manufacturer can't possibly know that. So they stamp on the one honest limit that never changes. The kilovolt amps. Let's put numbers on it. For three phase, apparent power equals the square root of 3, about 1.732, times the line voltage times the line current. Take a 50 kilovolt amp transformer at 208 volts. How much current can it push? Rearrange. Current equals 50,000 volt amps divided by 1.732 times 208. That's about 139 amps. That current is the real limit, and it does not care about power factor, which is exactly why the label is in kilovolt amps. Feed it a power factor of 0.8 and the real work it delivers is 50 times 0.8. 40 kilowatts. Same transformer, fewer watts. So, three phase gives you smooth power, self-starting motors, and less copper. And kilovolt amps is the equipment's honest limit, while kilowatts are the work it happens to do. Remember, kilowatts equals kilovolt amps times power factor. Next time, back to the board. Grab a pencil, and I'll see you there.